Hi, hello, this is Giri, teaching 10th Mathematics, the chapter sets. Here is the questions and solutions from exercise 2.1 and this is the part 1 video. In this video, we will learn the questions and solutions from exercise 2.1. This is the chapter sets and exercise 2.1. And let us solve questions and solutions from this exercise. Here is the first question. Which of the following are sets and justify? I shall repeat the question. Which of the following are sets and justify? Here is the first bit. The collection of all the months of a year begin with letter J. I shall repeat. The collection of all months of a year begin with letter J. We know that there are 12 months in a year. Starting from January, February till December, there are 12 months in a year. Out of these 12 months, now what are the months that may start from J? January, July, June and July. Okay, therefore it is well defined. If you bring some August, you can say that August does not belong to this collection as it is not start with J. If you say some March, you can say that the March should not belong to this collection as it doesn't start with J. If you say July, you can say that July belongs to this collection as it starts with J. Therefore, it is well defined. Since it is well defined, it is a set because it is well defined. Months are January, June and July. Therefore, how many elements are there in this set? In this set, there are 3 elements, January, June and July. Second question. The collection of 10 most talented writers of India. The collection of 10 most talented writers. Most talented writers means, in my opinion, there may be some 10 writers which are most talented. But in your opinion, the talented writers may change from person to person. Therefore, it is not well defined. You see the answer? Not a set, because talented writers may change from person to person. Not a set, because talented writers may change from person to person. Therefore, it is not well defined. Since it is not well defined, it is not a set. Third question. A team of 11 best cricket batsmen of the world. A team of 11 best cricket batsmen of the world. Again, if you ask your friend, he may give 11 best batsmen list. If you ask your another friend, he may give some other names. Some names may be coincide, but the remaining names may differ from person to person. But all 11 best batsmen may not be same for all the persons you ask. Therefore, it is not well defined. Since it is not well defined, it is not a set, because best cricket batsmen may change from person to person as per their opinion. Fourth question. The collection of all boys in your class. The collection of all boys in a class. It is sure it is a well defined, because if you bring a boy, you can certainly say that that particular boy may belong to this class or not. You can certainly say. Therefore, it is well defined. Since it is well defined, it is a set. It is well defined. If you find a boy, you can say that he belongs to your class or not. Therefore, it is a set. Next question. The collection of all even integers. All even integers. It is also well defined. If you bring an odd integer, you can say that that odd integer does not belong to this collection. If you bring an even integer, you can say that the even integer belongs to this collection. Therefore, it is well defined. Since it is well defined, it is a set. Because it is well defined, you can justify whether the given number is an integer or not. Whether the given number is an even integer or not, you can say. Now, question number 2. If A is equal to set 0, 2, 4, 6 and B is equal to set 3, 5, 7 and C is equal to set of P, Q, R, then fill the blanks with belong to and does not belongs to. Here is the symbol for belongs to and this is the symbol for does not belong to. Now the blanks are, the first one is 0 blank A, and the second bit 3 dash C, and third bit 4 dash B, fourth bit 8 dash A, fifth bit P blank C, and sixth bit 7 blank B. Here you have to fill up these blanks either with belongs to symbol or with does not belong to symbol. Here this belongs to symbol is to be used in between an element and a set. If that particular element belongs to a set, then you can keep belongs to symbol. You can write belongs to symbol if an element belongs to the set. If that particular element does not belong to the set, then you have to use this does not belong to symbol. Now let us use these two symbols and let us fill up these blanks. Here the first blank is 0 dash A. If you observe the set A, what are the elements in set A? 0, 2, 4 and 6. Since 0 is an element in A, we can write 0 belongs to A. And second bit 3 blank C. Now if we observe the set C, you can find P, Q and R are the elements of C, but 3 is not an element in C. Therefore, you should write 3 does not belong to C. And third bit 4 dash B. In set B, you can find 3, 5 and 7 are the elements of B, but 4 is not an element of B. Therefore, you should write 4 does not belong to B. And fourth bit 8 dash A. Set A. In set A you cannot find 8, therefore 8 does not belong to A. And fifth bit P blank C. In C you can observe P, Q and R elements, therefore you can write P belongs to C. And sixth bit 7 blank B. In set B you can find 7 as an element of B, therefore you should write 7 belongs to B. Now the question number 3. Express the following statements using symbols. I shall repeat. Express the following statements using symbols. Here is the first bit. The element X does not belong to set A. Then how can you write this using symbols? Since X does not belong to A, you should write X does not belong to B. And second bit, D is an element of the set B. The solution, since D is an element, you can write D belongs to B. And third bit, 1 belongs to the set of natural numbers n. Since 1 is an element, you can write 1 belongs to n. And fourth bit, 8 does not belong to set of prime numbers P. The solution, since 8 does not belong to P, 8 is not belong to P. Therefore, the symbol belongs to is to be used in between an element and a set if that element belongs to the particular set. If an element is in that set, you can use belongs to symbol like this. But if a particular element does not belong to the set, if the particular element is not present in the set, then you can write does not belong to symbol like this. Now next question. Now question number 5. Write the following sets in roster form or list form. Roster form means you have to list out all the elements of a particular set in between set brackets, then this is called roster form. We already learned what is the roster form and what is the set builder form. You see the first bit. X is such that X is a natural number less than 6. Now what are the natural numbers less than 6? Yes, 1, 2, 3, 4 and 5. Therefore, if we write all these elements 1, 2, 3, 4 and 5 within set brackets, then this is called roster form or list form. Now look at second bit. X is such that X is a 2-digit natural number whose sum of digits is 8. Here, if you observe this, I have given 2-digit natural numbers. You have to list out all 2-digit natural numbers in which the sum of the digits should be 8. Now, in order to get 8, now what are the different 2-digit numbers whose sum of digits is 8? They are 17, 26, 35, 44, 53, 62, 71 and 80. If you list out all these elements within brackets, then this is roster form or list form. Now third bit, x is such that x is a prime number which is a divisor of 60. Prime divisors of 60 you have to list out. What are the prime divisors of 60? 2, 3 and 5. Of course there are so many divisors for 60. One is a divisor of 60. 2, 3, 4, 5, 6, 10, 12. All these are divisors of 60s. But out of all these divisors, only 2, 3 and 5 are prime numbers. In order to write down the letters, no element is to be repeated in sets. In sets, you should not repeat any element. Therefore, we have to write only 2, 3 and 5. Now question number 4. X is such that X is set of all letters in the word better. Therefore, in order to list out the letters in better, now what are the different letters in better you have to list out. B is one letter, E is another letter, and T is the third letter, and R is the fourth letter. Therefore, the better word is formed with only 4 different letters. Therefore, you have to write the set of B, E, T and R. Even though T came 2 times and E 2 times, you should not write E and T 2 times, because in sets the general usage is you should not repeat any element. Now question number 6. Write the following sets in set builder form. I shall repeat. Write the following sets in set builder form. So far in question number 5, we have given the question in set builder form and we wrote in roster form. Now in this, we have given the sets in roster form and you have to change them into set builder form. Look at the first bit. The first bit is set of 3, 6, 9 and 12. 3, 6, 9 and 12. If you observe all these elements, what is the common property that these elements are having? If you observe these elements, 3, 6, 9 and 12, you can write 3 as 1 into 3, 6 as 2 into 3 and 9 as 3 into 3 and 12 as 3 into 4. Therefore, first is 3 into 1, 3 is 3 into 1, 3 into 2, 3 into 3, 3 into 4. Therefore, you can write this as 3 times of x. The given elements are the multiples of 3. Now, how many multiples of 3? 1, 2, 3 and 4. First 4 multiples of 3. Therefore, you can write 3x such that x belongs to set of natural numbers and x is less than 5. Less than 5 and natural numbers means 1, 2, 3 and 4. If you substitute x is equal to 1, you will get 3 into 1 is 3. First element. The second natural number is 2. 3 into 2 is 6. Second element. The third natural number is 3. 3 into 3 is 9. Third element. And the fourth natural number is 4. 3 into 4 is 12. That is the fourth element. You should not take 5 because x is less than 5. Therefore, the set 3, 6, 9, 12 in roster form is changed into set builder form like this. 3 times of x such that x belongs to n and x is less than 5. This is symbolic form. In terms of words also you can write this as x is such that x is the first 4 multiples of 3. In this manner also you can answer. Now second bit, 2, 4, 8, 16, 32. These are not the multiples of 2. Even though you can observe this is 2 times of 1, 2 times of 2, but 2 times of 3, 6 is not there. Therefore, these are not multiples of 2. Then what happened? Then this is 2 power 1, this is 2 square, this is 2 cube, 2 power 4 and 2 power 5. Therefore, the given elements are in the form of 2 power x such that x belongs to set of natural numbers and this is 2 power 5. Therefore, you can write x is less than 6. X belongs to n and x is less than 6 means the natural number is less than 6. 1, 2, 3, 4 and 5. Now if you substitute x is equal to 1, 2 power 1 is 2, If you substitute x is equal to 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16 and 2 power 5 is 32. Therefore, you can write the given roster form like this in set builder form. This is symbolic form. In words, you can write this as x such that x is the first 5 powers of 2. And third bit, 5, 25, 125 and 625. Again, these are the powers of 5. 5, 5 square, 5 cube and 5 power 4. Therefore, in the same model, you can write this as 5 power x such that x belongs to n and x is less than 5 here. In other words, x such that x is the first 5 powers of 5. And fourth bit, set of 1, 4, 9 and so on 100. 1 is 1 square, 4 is 2 square, this is 3 square and so on, it is 10 square. Therefore, in set builder form you can write this as x square such that x belongs to set of natural numbers and x is less than 11. Now what are the natural numbers that less than 11? 1, 2, 3, 4 and so on up to 10. 1 square, 2 square, 3 square, 4 square, 5 square and finally 10 square. These are the values. Therefore, you can write the set 1, 4, 9 and so on 100 as x square such that x belongs to n and x is less than 11. Or in words, x such that x is the square of first 10 natural numbers. Now, question number 7 now. Write the following sets in roster form. I should repeat. Write the following sets in roster form. Here is the first bit. A is equal to set of x such that x is a natural number greater than 50 but less than 100. Number greater than 50 but less than 100. Since they are greater than 50 and less than 100, you have to exclude them. You should not write 50 and 100. You should start from 51. Therefore, in roster form you can write A is equal to the set of 51, 52, 53, 54 and so on up to 99. Second bit, B is equal to set of x such that x is an integer and x square is equal to 4. Now you have to list out all the integers whose square is 4. If you observe, if x square is equal to 4, then x is equal to root 4. Square root of 4 is plus or minus 2. Since it is an integer, you can mention both plus 2 and minus 2. But it is given that if x is a natural number, you have to write only plus 2. But since it is mentioned as an integer, you can write plus 2 and minus 2 also. Now third bit, D is equal to set of x such that x is a letter in the word loyal. In loyal, L repeated 2 times. But you have to mention only once. And what are the different letters in loyal? L, O, Y, A. Therefore, D is equal to set of L, O, Y, A. This is the roster form. Now question number 8. Match the roster form with set builder form. I shall repeat, match the roster form with the set builder form. Here is the first bit, set 1, 2, 3, 6. On the other side, x is such that x is a prime divisor of 6. And second is set 2, 3. And B is x such that x is an odd natural number less than 10. Third bit, MATHICS. And on the other side, option C, x is such that x is a natural number divisor of 6. And fourth bit, the set 1, 3, 5, 7, 9. And the option D, x is such that x is a letter of the word mathematics. While matching, if you observe these 1, 2, 3 and 4, straight away it is very clear that MATHICS are the different letters in the word mathematics. Therefore, you can straight away match the third to D. And also 1, 3, 5, 7, 9. X is such that x is a prime divisor of 6. No, these are not prime divisors. as 9 is not a prime number. And x is such that x is an odd natural number less than 10. If you observe 1, 3, 5, 7, 9, these are the odd natural numbers and less than 10 also. Therefore, you can join fourth bit to B. Fourth bit answer is B, third bit answer is D. Now look at 1 and 2. 1, 2, 3 and 6. Option A, x is such that x is a prime divisor of 6. No, 6 is not a prime divisor. Since 6 is not a prime divisor, it is not this option. But here x is odd natural number, it is already given. And x is a natural number divisor of 6. Therefore, you can join 1 to C. Therefore, 1 to C and 2 and 3, elements 2 and 3. 2 and 3 are the prime divisors of 6. What are the different divisors of 6? The different divisors of 6 are 1, 2, 3 and 6. But whereas in 1, 2, 3, 6, 1 is not a prime number and 6 is not a prime number, only 2 and 3 are prime numbers. Therefore, this second bit, 2, 3, the set 2, 3 are the prime divisors of 6. Therefore, the first bit answer is C, second bit answer is A, third bit answer is D, and fourth bit answer is B. Thank you one and all.